Hello class and welcome to Unit 2, Video 5. Today we're going to look at graphing inequalities and absolute value equations along with inequalities. The learning targets for today are that you can graph two variable inequalities, so two variable means x and y, and I can graph absolute value equations and inequalities. So we're going to look at graphing two variable inequalities first. So in order to graph inequalities, they can be graphed in a similar way as linear equations and absolute value equations. Okay, so whenever we're graphing them, you're going to graph them as you would a linear or an absolute value. The equation just serves as a boundary to the area representing the inequality. So the shading, we're going to be doing some shading today that will represent our inequality. Some things to remember: if I have less than or greater than, that requires a dotted or dashed line. Dotted or dashed. Either way, if I refer to one, I mean the same thing. So dotted. If it's equal to, that's going to be your solid line like you typically would do. Okay. So when it's not equal to, dotted or dashed, same idea as an open circle. And if it's equal to, it's a solid line. So we want to go ahead and graph this. There's two ways you can graph it. The first way you could graph it is you could find your x-intercepts. Okay. To find your x-intercept, remember that's when you let y equal 0. So we have, that's when y is 0. So if I plug in 0 for y, this is essentially gone. And if I solve this for x, I would get 6 divided by 2. So x will equal 3. So my ordered pair for my x-intercept is 3. If I find my y-intercept, that is when my x value is 0, so I plug in 0 for x. So I'm left with 3y is equal to 6, so y is equal to 2. So I would have those two ordered pairs. Okay, so I could graph it that way, 3, 0, and 2, 0, and I could draw a line between those. And notice, we're going to have what kind of line? A dashed. So one method is to find your intercepts. Your other method is to put it into slope-intercept form. Okay, so if I put this one into slope-intercept form, I'm going to solve it for y equals. So if I would subtract 2x from both sides, so I have 3y is greater to negative 2x plus 6, and then I would divide everything by 3. So y is greater than negative 2 over 3x plus 2. So this one, my slope, which it asks you for on your note sheet, is negative 2/3. So this is your slope. So your other option is to find your slope-intercept form and then plot. You have ordered pair of 2, and then it's down 2 to the right 3, down 2 to the right 3, or up 2 to the left 3. Okay, this would get another way to get your equation. So I would do my very best, and you guys have your, you can use a straight edge to do yours, but this one's going to be a dashed line. Okay, so there is my dashed line, and now I have to shade. A lot of people forget to shade. You don't want to do that. So there's two ways you could do it. It says y is greater than, and if I think greater, I'm going to think bigger or above my line. So I know I'm going to shade above. The other way is to check a point. I like to check 0, 0 if it's not on my line. So in this case, 0, 0 is not on my line. So I am going to check that ordered pair, and I'm just going to plug 0 in for x and 0 in for y into my original. So I really have 2 times 0 plus 3 times 0, and is that greater than 6? Well, this will give you 0. Is 0 greater than 6? No, that's false. So what that means is the ordered pair 0, 0 is right here. It's not a true statement, so I do not want to shade where it's 0, 0. I want to shade away from it. Notice how the ordered pair 0, 0 is not in my shaded part. So here is my answer on my graph. Okay, let's go ahead and look at example 2. Once again, we need to graph. We can either do intercepts, or we can put it into slope-intercept form, doesn't matter. So I'm going to find, I'll do both right again. So my x-intercept, remember, is when y is equal to 0. So I have that ordered pair and when y is 0. So if I plug in 0 here, this is gone. So I have negative x is equal to 4. So x is equal to negative 4. So it's negative 4, 0. My y-intercept is when x is equal to 0. So I'm going to have 0 here. And if x is equal to 0, this piece is gone, so it's really 2y is equal to 4. So y is equal to 2. Okay, so once again, I could use those ordered pairs and graph my line. Okay, if you like to find intercepts, there would be my line. This one is going to be a solid or dashed. It's not equal to, so it is a dashed line. Okay, so I could go ahead and put my dashed line in now, or your other option again would have been to find your slope. So I would add x to the other side, so I have 2y is greater than x plus 4, and then I would divide everything by 2. So y is greater than 1/2 x plus 2. So my slope for this one is 1/2. So I would start at my y-intercept at 2, go up 1 over 2, up 1 over 2, or down 1 to left 2, down 1 to left 2. So either way works. As you can see, you'll still get a line. And then we're going to do a dashed line. All right, then I check my point to see which way I shade. Once again, I could use this method. Y is greater than, so greater I would think, well, to be greater I'm going to be above, but let's check my ordered pair 0, 0. So I would plug 0, 0 into my original, so we're going to check 0, 0. So it's when x is 0 and y is 0, so I have negative 0 plus 2 times 0. Is that greater than 4? Well, negative 0 plus 2 times 0 is all 0. So on my left-hand side, I have 0. Is 0 greater than 4? That is false. So I do not want to shade where the point 0, 0 is. I want to shade on the other side, which is also greater than or above. So my answer for number 2 is there. We're going to move on to a word problem. So if you have any questions on examples 1 or 2, please write them down and come and ask. All right, number 3, Manny has $15 to spend at the fair. It costs $5 for admission and 75 cents for each ride ticket and 25 cents for each game ticket. Write an inequality for the number of ride and game tickets he can buy. So, number of ride, we're going to let that be x, and the number of game tickets, let that be y. So let's just talk about how much it's going to cost. So off the bat, he has to pay $5 to get in. Plus, he's going to spend 75 cents for each ride ticket, which is x. Plus, he's going to spend 25 cents for each game ticket, which is y. Okay, this is how much money he's going to spend. And it has to be, he only has $15 to spend. So it has to be less than or equal to 15. This can't be bigger than 15 because if it is, he doesn't have enough money. So let's just go ahead and simplify this a little bit. Let's move my 5 to the other side. So I really have 0.75x plus 0.25y is less than or equal to if I subtract $10. Okay, so really he only has $10 to spend on tickets. So if he buys 10 game tickets, how many ride tickets will he be able to buy? So my game tickets are y, so I'm going to plug 10 in for y. So I would have 0.75x plus 0.25 times 10. That has to be less than or equal to 10. Okay, if I multiply 0.25 times 10, I'm going to have 2.5, so $2.50 is less than or equal to 10. And if I am solving this, I would subtract 2.5, and if I subtract, I get 7.5. So I have 0.75x is less than or equal to 7.5. And then if I solve this one, I would divide both sides by 0.75. If you take 7.5 divided by 0.75, x is less than or equal to 10. So if he buys 10 game tickets, how many ride tickets will he be able to buy? He can buy no more than 10 ride tickets. Okay. Moving on to the next problem, it says, what is the maximum number of ride tickets he can buy? Okay, so to be the max number of ride tickets, that would be when he doesn't buy any game tickets. So we're going to let our game tickets be 0, which is y. So we have 0.75x plus, that means we're not buying any game tickets, so that's 0. That has to be less than or equal to 10. So this is 0, so I really have 0.75 is less than or equal to 10. And if I take 10 divided by 0.75, I get 13 point, sorry, there's an x here. So x is less than or equal to 13.3 repeating. Okay, well, can I buy 0.3 tickets? No, because it has to be less than. So he can buy 13 or less tickets. So this one would be no more than 13 ride tickets. So the very max that he could buy is 13, but that means that he doesn't buy any game tickets. And then lastly, if I want to find the max number of game tickets, well, that's when I don't buy any ride tickets, but my ride tickets are X, so I'm going to put in 0 for that. You want to know when that's less than or equal to 10? So this is 0, so then if I want to do this, I would divide 10 by 0.25, which gives me 40. So y is less than or equal to 40. So he can buy more game tickets, but his max number of game tickets is 40. So he can buy no more than 40 game tickets. And that is if he buys 0 ride tickets. Okay, so that's example 3. If you have any questions on that, please let me know. Otherwise, we're going to go ahead and move on to absolute values. Absolute value functions. We've already graphed these. Just a little reminder, what's inside the absolute value with x shifts the graph left or right. Okay, so in order to do this, we want to set the expression inside equal to 0 and solve for x. This will give you the x coordinate of your vertex. The number on the outside gives you that y vertex of your y coordinate of your vertex, and it is whatever number is being added or subtracted, exactly like you think. So for this example, okay, you can think about it as whatever is opposite in here. So opposite of positive 5 is negative 5, and then up 7. Or what they're saying is whenever you have this, you can take the inside, set it equal to 0, and that gives you your x value. Okay. So we're going to be using the idea of a vertex to graph absolute values again today. The only difference is they are inequalities. Okay. The first one, though, is an equation, so we're just going to graph it. So we're graphing it. The first thing I want to do is find my vertex. Take what's on the inside, set it equal to 0. I get negative 1. So my vertex is negative 1, and my y value will be on what's on the outside, so negative 2. Then I want to go ahead and pick two numbers that are less than this, so negative 2, negative 3, and two numbers that are bigger, so 0, 1, and plug them in. Negative 3 plus 1 is negative 2. The absolute value of negative 2 is 2. 2 minus 2 is 0. Negative 2, plug it in. Negative 2 plus 1 is negative 1. The absolute value of negative 1 is 1. 1 minus 2 is negative 1. Plug in 0. 0 plus 1 is 1. Absolute value of 1 is 1. 1 minus 2, negative 1. And if I plug in 1, 1 plus 1 is 2. Absolute value of 2 is 2. 2 minus 2, 0. Now I'm going to go ahead and plot these. So I have negative 3, 0, negative 2, negative 1, negative 1, negative 2, 0, negative 1, and 1, 0. So there is my absolute value function graphed. Remember what it looks like. It should look like a V. I would recommend getting out a ruler or a straight edge or something so you make your graphs nice and straight. Okay, so that's example 4. Let's go and look at example 5. Okay, so we need to find the vertex again. The way you do that is you look what's on the inside. Sorry, what's on the inside. And it's always the opposite. Okay, so this one, remember, if it looks like it's going to the left, it really went to the right 4. And this piece tells me it's going up 1. So my vertex is really 4, 1. The other way you can find the x value, remember, is x minus 4 equals 0, so x equals 4. Okay, so those are my values. Then I pick two numbers below, so 3 and 2, and two numbers above, 5 and 6, and I'm going to plug those into my original equation. Okay, so plugging them in. 2 minus 4 is negative 2. Absolute value of negative 2 is 2. 2 plus 1 is 3. Plug in 3. 3 minus 4 is negative 1. Absolute value of negative 1 is 1. 1 plus 1 is 2. Plug in 5. 5 minus 4 is 1. Absolute value of 1 is 1. 1 plus 1 is 2. And 6 minus 4 is 2. 2 plus 1 is 3. Should start to notice a pattern that it's symmetric. So if this is my vertex, see how my y values pair up. So let's graph this one. 2, 3. 3, 2. 4, 1. 5, 2. And 6, 3. And I would look and I would see it's an equal sign, so I just have to graph it. Okay, and there is example 5. Okay, so those are absolute value equations. Now we're going to go ahead and graph an absolute value inequality. So this case, same idea, start with your vertex. Was this one moved at all? Is there any values inside there? No, it wasn't, so it's at 0, wasn't moved at all. This one tells me it was moved down 3, so it's 0, negative 3. Now I go ahead, numbers less than 0, negative 1, negative 2, numbers greater, 1 and 2. So if I plug in negative 1, absolute value of negative 1 is 1. 1 times 2 is 2. 2 minus 3 is negative 1. Plug in a negative 2. Absolute value of negative 2 is 2. 2 times 2 is 4. 4 minus 3 is 1. Plug in negative 1. Absolute value of 1 is 1. 2 times 1 is 2. 2 minus 3, negative 1. And once again, guesses are it's going to be 1, but let's try it. 2, absolute value of 2 is 2. 2 times 2 is 4. 4 minus 3 is 1. So let's plot those. So we have negative 2, 1, negative 1, negative 1, 0, negative 3, and 1, negative 1, and 2, 1. So once again, symmetric. Now, it's an inequality. This tells me it has to be a dashed line. So I'm going to do a dashed line. All right. And then to figure out which way I shade. It says y is greater, so to be greater, I'm thinking shade above, so on the inside, but you might not know or you may not be able to see that. So I check a point. I'm still going to check this point, 0, 0. So we check. So with inequalities, you can always just check a point, 0, 0. Is 0 greater than 2 times the absolute value of 0 minus 3? Well, this gives me 0. 0 minus 3 is negative 3. Is 0 greater than negative 3? That is a true statement. So this time I want to shade where that point is. So there is my answer for number 6. Okay, that will be the end of Unit 2, Video 5. If you have any questions, please let me know. Otherwise, have a great day.